Video 3 on random sampling. We're investigating variability from various distributions. Now, we've looked at variability in the past in terms of standard deviation and variance. So yeah, they're the measures of variability. Okay, and random samples, I guess we know intuitively, will vary unless we use the whole population. Okay, so if we take a sample, take a different sample, we get different data. Here's a slightly ridiculous example. If we have a small population of 5 elements, we could take samples of n equal 2, and you can get all sorts of things, and clearly they're very different. Okay, so small samples, if you base a decision on, say, that one and that one, that is pretty misleading, alright, because you're really only just capturing part of it. So really small samples is a bit ludicrous, and that's probably an exaggerated way of looking at it, but we need to be careful of the quality of our surveys and the variability, and that's an extreme case of variability. Okay, so variability investigations can be done based on sample data from various distributions, and the ones we've seen before, like uniform distributions, normal, Bernoulli. Okay, and if they're drawn from real data which fit those distributions, we can find, if we do enough of that, we can find that each sample is different. Okay, it's highly likely that you choose a sample, another one will be notably different. So this means, by difference, we mean the mean standard deviations. Okay, highly likely that they're going to be different from one sample to the next. However, we can mitigate this with larger samples. Okay, so with larger samples, they actually are more similar. So we've got to have the samples of a decent size, and we're going to develop that idea. Okay, so contents of a random sample will vary from sample to sample, we can conclude. Understanding the nature of this variation and what a random sample can tell us about the population from which it's been drawn is important. Okay, that's an important concept, and there's just 3 examples of, if we had the same mean, but we've got different, same sample size, but we've got different data. Okay, so we can see the now we've got the normal distribution over the top, but we can see the histograms in each case quite different. Even though we had a decent sample size of 50, we needed probably more of a sample size there. So I've tried it with a uniform distribution. So by simulating a uniform distribution, and I've used 5 times rand open close brackets plus 5 to create numbers between 1 and 20. There it is, I was starting to write off the screen there. So 5 rand open close brackets plus 5, because it's based on a uniform distribution of this, and else 0. Okay, it's a piecewise one. So that's a uniform distribution, alright, 1/5 x, and basically we can see, if we have a look there, you can see, get that writing out the way, that we've got all the data there, and I've 1, 2, 3 trials, that's what the 3 columns mean, and I did a box plot of it, and you can see for those 3 trials, blue, orange and green, that there's variability. Okay, the box plot can show you the different sort of mean, or in this case it's the median actually, and the spread. Okay, I could have done it for histogram as well. Variability.